Welcome at PASC25. These are highlights from the conference. I have the pleasure here to have Professor Alberto Figueroa from University of Michigan, and you were the invited public lecturer of PASC25, and you gave a very interesting lecture. I will read the title because it's a bit too long and it's difficult to remember by heart, but it's Machine Learning Assessment of Coronary Artery Disease using X-ray angiography. The title is very complex, but actually I enjoyed a lot your presentation. But can you summarize what was the main message of your presentation?
Thank you. The main message of my presentation was to try to rely on computational and machine learning methods to extract a lot more information from angiograms, which are routinely done in patients that have heart disease. Yeah. So an angiogram is a picture of the vessels in your heart. And historically, the angiograms are only used to make very superficial decisions on whether a patient needs a stent or a surgery. And those decisions, simply, they just look at the vessels and they just say, oh, they are occluded or not. With the power of computers, with the power of physics and machine learning, we realized that we can extract a lot more information, not just about how occluded the blood vessels are, but whether they are performing their function well or not. And their function, of course, is to feed the heart.
So you basically are helping cardiologists, so medical doctors, to diagnose better? Is this a fair statement?
That is exactly what it is, yes. They have a modality that is underutilized as far as what powerful or amount of information it can give them.
And I assume that this is also very important because I heard you saying in your talk that actually heart disease are the major cause of death in the Western world. So it is important to help, I guess, I mean, the people on that they are really working with patients to be able to also speed up the diagnosis. Is it true that you said that when they use this approach, patients are basically
on the table.
On the table, yep. Thank you.
Yes, yes. These approaches. This is one of the real benefits of machine learning methods, which is something you can leverage to make a computation that can be very expensive. You can make it very fast, and indeed, in some. Patients can be taken to an imaging system in various different stages of diagnosis. Sometimes they can just go to a CT scan and they go back home. These are not the patients we are dealing with. We are dealing with the patients that are more advanced in a disease stage, and they are literally on the table and potentially very close to getting an intervention. So there's a difference between diagnosis, which is, do I need to do something? And then intervention, which is, I'm going to do something, and this is going to be, I'm going to put a stent, or I'm going to do a bypass surgery, or something like that. So the speed in which you have to do the analysis is indeed very important.
And I know that you hinted on what are the next steps, because you said that now you have a private company that will take this method or approach that you developed in academia. Can you tell us a little bit more about it?
Yes. So this is a spin-off from the University of Michigan, which is where I work. The name of the company is called Angio Insight. Angio because it's angiography. And it's to me, it's been, I never thought that as a professor I would be involved in entrepreneurship, but it just happened naturally right before COVID. And it brings a whole new set of activities that are actually quite compatible with academia. Instead of writing papers, or in addition to writing papers, you also have to write patents, which is intellectual property, which is the main asset of a young company. And then obviously you need to think about getting money for the company. That's not too different from what, at least in the United States, as a professor, you need to get money for your lab. But this is money for your company. And then at some point, the company just starts running on its own wheel, so to speak. I remain full-time faculty. I'm not working in the company full-time. I'm just the chief science officer. Yeah. But it's nice to see how people working at the company, some of them are former students, they go through all the stages that are necessary to take a software and an idea to first regulatory. You need to work with the FDA. At some point, they will have to deal with the European regulatory agency. And then you need to deal with a clinical trial that really tests whether your product works. There's a whole new set of products known software as a medical device. So the software plays the role of a medical device, a diagnostic medical device that instead of sticking a wire or having a pressure sensor, you rely on quote unquote smart post-processing and analysis of the images.
So this is an amazing, amazing message because it's, first of all, is a very nice application of these machine learning approaches to real life and actually to try to solve real problem because our disease are a real problem affecting a lot of people. So I thank you again for joining us and for giving us an additional summary of this amazing public lecture at PASC25. Thank you.
You're very welcome. I want to say that this is one of the most unique conferences I have attended. From the concept of a public lecture that is open to the public to even the way the poster sessions are handled is wonderful, and I'm very impressed with the healthy state of science here in Switzerland.
Thank you very much for this additional positive message. Thank you very much.
You're very
and
welcome.
thank you all.